Good morning everyone. I'm Dr. Nidhika Yadav and today I will be presenting to you solutions for NLP problems. I will be presenting the broader solutions for solving NLP problems. Means we are given an NLP problem, we want to know how to solve it. What are the tools available for us? What are the AI tools available for us? What are the other tools available for us to solve an NLP problem? So this is a short lecture to tell how to solve an NLP problem. What does solving an NLP problem means? To attain the goal of a NLP problem. So what is the goal of an NLP problem? For example, we are given in 2022, the latest challenges in NLP are like fake news detection, right? A good recommendation system algorithm. So you are given a task. We have been given a fake news. We want to know, we want to detect it is a fake news or not. So how would we do it? For that, we need some tools. I have been given a news. It is a one-page news and I want to detect if it is a fake news or not. So how would I do that? For that, we need to know the tools available to us. What are the tools of NLP problem solving that we can use? I'll be discussing those tools, those algorithms, those techniques that it can be used to solve the NLP problem. For example, you want to develop a social media platform and you want a good recommendation system algorithm. Good in that sense means you want an algorithm that can solve the problem. That means that can give the feeds to the users that the users would like and are of interest to users and are beneficial to users, right? For example, your social media company or social media platform that you wants the best news, most relevant news, most useful news and any other news that is informative to the user to be given to it. Artificial intelligence and NLP tools are like personal secretaries of people, right? These are softwares that serve the people. So we want the best recommendation system algorithm for a person so that he gets the best news. And for example, the latest thing is that is in news is best recommendation system algorithm that can solve teenagers problem that teenagers are not given and children are not given wrong information. For that we need the right recommendation system algorithm. So how do we do that? So this is one problem. We have a problem of fake news detection. I've got a news, I want to know what is fake news or not. Next is there's a recommendation system algorithm. I want to know how to implement it. What are the tools available to us? So today in this lecture I will be discussing what are the tools that are available to us through which we can solve the NLP problems, right? And the NLP problems are not restricted to just the recommendation system and the fake news detection. It can be any NLP problem. For example, we have a new word in the dictionary, a new slang, right? A new slang has come and we want to know how to use it. It is appearing in certain context and we want to know the context of the word, right? Any new slang, a short form. For example, you write LOV, instead of that you write LV and it is used in certain sense in text, right? For example, on chatbots these days, people use short forms. For example, bank is written as BNK and somebody says it's a word system big issue. So how would you do that? So there are lots of problems in NLP. For example, a child speaks something, his speech recognition has certain constraints that can be adult speech recognition problems may not fit into it. A child's speech recognition problem would be a little different than an adult speech recognition because this is a different way in which the child speaks. A little non-mature way. So the speech recognition may not be able to exactly classify that till right things are imposed. So if this new problem is given to you, child speech recognition problem. So how would you solve it? What are the tools available to you? Right? And there would be certain words that you would be able to disambiguate in speech recognition, right? Speech recognition is part of NLP because these are natural language. We are communicating via natural language. Natural language is human languages. It can be machine to machine talk also. But the thing is, these are natural languages that humans or living species do. We are not talking about machine languages, right? right? We are not talking in assembly language, compilers, what you compile as an assembly language of bits and zeros and ones. No, we're talking of natural language, the communication between living beings, right? This is what is the topic, and any problem, any other problem can be given. Machine translation, information retrieval, you have a new, for example, you have a new word and you want to find the relevant articles related to it, right? So for that we need an information retrieval model. A new problem has come in. So natural language processing, it is not that old problems are there and that is all we have done. No, every day new problems come in natural language processing. Every day, right? So we have a new word, new problem, there are new people coming in, new entities coming in, new products are developed, a new product is developed. For example, after Alexa, something new comes in and we want to know about that, right? We want to do the video, image and the voice processing of that, and we want to find out certain things, that what are the relevant related things, and we want to do image processing based on that. Information retrieval based on that. So how would we do that? It would need image processing as well as text NLP data, both things, because it is a video. It has both the image processing thing and as the NLP thing. So these are the examples that why we need to study natural language processing, problem solving, right? It is about problem solving as a general thing. That these are the tools available to us, and we know, for the examples that I have given in past 5 minutes, we know that what are the challenges NLP is facing. We have information growing every day information is growing, so we need every day new problem solving, right? We have new problem solving challenges every day. We need to know how to solve that. So there are certain set of solution guidelines that I'm going to tell today, and in the coming time I will be explaining to you each of these problem solving techniques in detail. So for example, one such thing is linguistic methods. Linguistic methods are rules that language experts make. For example, somebody is a German expert, somebody is a Hindi expert, somebody is a Sanskrit expert, somebody is English expert. So what are the rules that the person would be telling about that? I mean, say for example, there are certain gender specific things. For example, in Hindi, I am going is converted to मैं जा रहा हूँ और मैं जा रही हूँ. So how would we actually, which solution we would select, which decision making we will do? That decision making would be done with the help of NLP solution finding techniques. And for that we need linguistic rules, right? Linguistic experts, the language experts, particular language experts who know the constructs of language, not just the AI algorithms from deep learning model which reads lots of books. What is these deep learning models? They read a lot of books and learn what are the ways in which languages is written. Statistical learning, neural learning, these are the learning, they learn the pattern in which the language means. For example, they would know that what was the context before, because they see the time series, they see what was talked before, what is talked after, and based on that they can determine the gender, right? So, but that is one set of thing to determine, for example, gender. The other thing is linguistic methods. So the first problem solving techniques is linguistic methods that are determined with the help of linguistic experts. Next is knowledge-based methods. For example, in a recommendation system, we need knowledge. For example, you are a student and you want to know, you want to have the best recommendation system algorithm for you. For example, for that, your the software, the social media platform that you use would be storing certain basic things about you, the kind of things that you search, the kind of things you like. They may ask you certain things, or they may learn based on your search history, or they may even ask based on any other things like what you type, or what kind of things you read, or what kind of things you view on YouTube or Spotify. So all those things, it is going to learn from that. And based on that, a recommendation system algorithm would be presented. And sometimes you're manually asked, sometimes it is automatically done. So those recommendation system algorithms will make rules out of your preferences that you are feeding into it, and those rules would be fit into a knowledge-based inference system. and they are going to get inference. So this is different from linguistic thing, because in linguistic thing we are given rules, right? We are writing the rules with the help of linguistic experts. In knowledge based system, rules are learned because we cannot write rules for so many people, right? So many people, rules cannot be written. There are so many people, so you use social media platforms, so automatically rules would be written, a knowledge base would be developed, an inference system would be applied, and recommendations would be provided to you. This is the difference. Next, we have a toolkit of supervised machine learning algorithm. We have a lot of supervised machine learning algorithm that we can use, and I'll explain in detail about these. They are text categorization, POS tagging, keyword extraction, machine translation, automated image tagging. All these use supervised machine learning techniques, but the drawback is we need a lot of training data for it, and we need to be have tag data. That is, we have to have the tag, the classification, the category. What is the category of the data, right? The classification, the target class. We need to know that, so that we can actually use and learn the supervised machine learning techniques to solve NLP problems. So NLP problems right now can be solved by linguistic methods, it can be solved by knowledge-based methods, it can be solved by supervised machine learning. Then there are unsupervised and semi-supervised method, in which we don't have the training data. For example, we can use clustering to detect fake news, recommendation system algorithms, word census ambiguity can be solved with the unsupervised learning algorithm, text summarization can be solved with unsupervised learning problem, retrieval to some extent can be solved with unsupervised problems also, if we have the query term that we need to find out. Then this is another toolkit we have. Another toolkit, next toolkit is graph-based methods and heuristic methods that we can use to solve NLP tasks. So what are graph-based methods? The graph-based methods are like, for example, the first, the information retrieval method, the page rank algorithm, the Google page rank algorithm relies on a graph algorithm, right? So there are other things like sentence similarity. The word net is organized in a nodes and interconnection between nodes model. So we can apply, there are algorithms that use all those things like sentence similarity to use word net, and word net is itself organized in nodes and interconnections. To some extent, there are certain graph constructs in it. Then summarization can be used in graph constructs. Every NLP problem can be used in certain different context of one of these tools that I'm telling you. These are the problem solving techniques. Heuristic methods. So for example, we have certain heuristics. For example, we are solving a text summarization problem. We have a heuristic that how much is the abstract that we are extract that we are developing different from the extract to abstract we are developing different from the goal. Goal is to cover the whole text and in the smallest number of ways. So this is the we need to know the span, right? Is the extract covering it? Is it spanning it? So that is the thing here. Next set of tools, and heuristic is telling that how much far away we are from the goal. The goal is to cover the whole text in minimum numbers of sentences. So these are the heuristic methods. There are a lot of other application heuristic methods. I'll explain in coming times. Next is optimization and numerical mathematical methods. So optimization techniques can be used a lot. There are typical analysis, greedy solutions, traveling salesman problem, dynamic programming, NAPSA problem. So sentiment analysis, information retrieval, or text summarization, keyword extraction. A lot of applications are there for optimization problems, and optimization like gradient descent is used for a lot of deep learning algorithms, and there are a lot of things in which optimization techniques are used. We can optimize the parameters used, and a lot of things that can be done. Numerical mathematical methods such as singular value decomposition, principal component analysis, non-negative matrix factorization. These are used a lot. For example, we have a set of a text collection. We want to actually show it on a graph, show it the word, like right now we have the word clouds, right? How do they compute? They use word embeddings, right? But earlier they used to use Latin semantic analysis and singular value decomposition to know how much words are related to it. Presence of word embedding does not say that these methods go off. They would be. I will discuss how these can still be used. So let me cover up. Next set of logic techniques are logic-based methods, propositional predicated logic, and next is reinforcement transfer learning, approximate reasoning, abstract mathematical science applications. Right, so these are the basic things. So logic based method, So logic-based method, for example, we have predicate logic and propositional logic. So predicate logic, how does predicate logic depends. Everything, if you see any discrete mathematics book, you would see everything is in natural language processing and predicate and propositional logic. So in this natural language processing thing, we say that it was cloudy today, hence it rained. Right, there is logic here, and there is a logical things in discrete mathematics called predicate propositional logic, but it doesn't cover everything. For example, it doesn't cover certain relation. For example, Tina loves Meena, right? So their relationships was missing, so predicate and complex higher level calculus was developed for that. For example, you can write Tina loves Meena as loves Tina Meena. So if you see anything on predicate calculus on discrete maths works, it involves language processing, but however, not recent any, I couldn't find recent references for this and that, but theoretically it is there. Next is reinforcement and transfer learning. There are a lot of tools available to us for NLP problems that we can use in reinforcement learning. For example, you are developing a robot that wants to learn continuously based on the feedback given to it, and it learns and it tries to improve. So there's a reinforcement learning in it. Transfer learning. For example, NLP problem I've already told you, they are growing with time, right? Every day we have a new data, we have new tool, we have new word, a new company opens up, a new product comes in market. So a new product means a new name means a new entity means a new thing in the this database or data servers, data centers, right? Internet. So we have a new word. This word is a natural language person. I developed a product, Tiku. So this product is a new thing, and we want to know what this, if somebody searches, what would be the search results for it, right? So for this, a new NLP task is developed. Right, we can use existing algorithms for searching it, but the challenge becomes a new, right? For example, it has to develop its own chatbot, it has to develop its own opinion mining things, and it has to do its own set of things, right? There will be certain synonyms that it should be related to. So all those things can be done in an efficient way. I'll discuss more on this later. So transfer learning is one such thing that when we have learned something on certain things, right? We have learned Tiku is a new product, and we have some learning on a similar product, right? A product was Piku, and on Piku we have done certain set of analysis. We have done supervised learning algorithms. We have learned a lot on it. So can the new product learn the same things based on the learned network of that with certain changes? The same parameters can be transferred here, and transfer learning can be used. Next is approximate reasoning. There are a set of solutions for approximate reasoning. For example, NLP task always have some set of approximateness to it. So what is approximateness? Approximateness. So basically the thing is, you say it's raining, so we don't know by this that it is raining heavy, it is raining low, it is raining very heavily. So there is certain set of approximation that there is always present in it, right? Uncertainty is there. So there is certain level of uncertainty. There's the natural language inherently inherits it. So, for example, a cat in a football ground with a red ball. So how would you tag it? Tagging of text images into a text string is a new thing. It is a very much used. However, deep learning models or large language models are used in it, but it is a very much thing. So approximate reasoning do help in it. Uncertainties are there. If you want to just select two keywords for it, which one would be using? A red or a cat or a football ground? Which of the three things we would be using? We don't know, right? There are certain set of approximateness and uncertainty in it, and decision making based on such uncertain conditions is called approximate reasoning. Is dealt with in approximate reasoning. We have to do decision making in these approximate conditions. So suppose I gave you example that it was raining, and it is raining, and I want to make a decision. Should we go out, or is it fine to go plan for something out, or would the milkman come today? So these decision making will the impact come today. It was raining. So how would you do? Not just pure precise logic, but there's certain set of approximateness involved. We have to see other sentences that were there, the conditions that were there, the environmental conditions, and the other relationship between them. So in such condition, approximate reasoning and uncertainty handling, these tools can be used. They are available to us. Last is scientific methods. Other scientific methods, abstract mathematics and scientific methods. So they are algorithms like we all know, for example, particle swarm optimization, the way a swarm works, the way a group of birds fly, group of fish fly, or whales do things, or ants find their food, right? So for that, there are certain biological logics, genetic algorithm. There are certain biological logics of crossover, mutations, how they happen, how selection happen, how survival of fittest thing works. So all those things are scientific things that are used now, and these things can have been used primarily as modeled as optimization problems or feature selection problems. They are used in these, right? And how they can be helped in NLP? For example, it can be used to optimize a network, it can be used to optimize a neural model, deep learning model, or learn parameters in any task. Even learn the rules. We can even learn the rules using these things. So these are set of lot of problems. Biological entities, how ant finds the food, how other ants follows it, what is the relationship, how birds find their path based on the path of the first bird and then the next bird, how they maintain the velocity and speed along with it. So there is logic behind it, there's science, and it has been converted to algorithms. They can be used in a lot of application for parameter optimization, for learning, and even for classifying, right? So this is a lot of applications, and abstract mathematics can also be used. For example, I myself have modeled certain NLP tasks using abstract mathematical models, and so these are the set of problems that are available to us to for given any NLP task. So I have given a brief overview. I have also given examples of what are the kind of NLP problems that can be solved with each of these. Once again, I am revising the things. The tools available are like linguistic methods can be used, right? You can call in a linguistic expert if you have an NLP problem, and the linguistic expert can explain you how. Maybe he may tell you to use a context-free grammar. He or she can context-free grammar. He or she may tell you that we can use certain kind of rules in maybe rule-based systems like Lem's algorithm or any inference engine algorithm that reads rules, a priori algorithm that finds rules. For example, say in a Walmart kind of data for finding the rules, like if you buy bread, then you will also buy a milk, certain kind of things based on the history of the buying of the customers that come to the Walmart store. If you buy milk and bread, then you will surely buy butter also. So it will recommend. Sorry, would you like to buy butter also, or would you if somebody buys clothes, and then she will also buy something like maybe a coat also, right? So certain kind of recommendations and rules can be made. So all those things are there. So but linguistic methods basically are different from these rules that are automatically determined, that can be used in recommendation system algorithm. But linguistic method rules we have to define, right? We have to define with the help of linguistic experts. So this was, I explained it because to tell you the difference between linguistic expert and automated knowledge-based systems that use automated rule generation techniques. So these are automated rule generation techniques. There are LEMS algorithms and LERS and many other algorithms that can be used to automatically generate rules that can be used in any knowledge-based systems, or the knowledge-based systems can also work on humanly entered, manually entered rules also. But those are not linguistic rules. Linguistic rules are by language experts. For example, it can be used in POS tagging, shallow parsing, machine translation, right? There are certain rules, gender specific rules, use of apostrophes, use of special words. For example, in German, you use Ubuntu like DEUCH, it's not just a U, Deutsch, right? So there are certain things. If you write Deutsch, the NLP engine will tell you, no, it's the DEU with the thing. And so certain things like these are there. Initially, we used to use Lex and Yark as writing tools, but there are various other ways in which this can be done. Second way, so we have discussed once again linguistic methods, knowledge-based method. I've covered knowledge-based also in this. Supervised machine learning techniques. Do you have the training data? Then yes, we can use supervised machine learning technique. Do you not have a training data? Then next, use unsupervised. You have some training data, use semi-supervised. Oh, you have a totally unsupervised, you don't have training data, you have nodes and interconnection. You know how these these natural language entities are connected to each other. We have certain kind of connection between these natural language entities. So we can use graph-based and heuristic-based method. We have certain heuristics available for the nodes. Of nodes means text data. The text data can be word, it can be sentences, it can be documents, it can be phrases, right? It can be files, and it can be any other things as well. So graph-based method. Then optimization and numerical methods. We want to optimize certain things. We want to minimize the time. We have certain constraints. There are certain constraints that we want only 10 keywords. This is a constraint. We want a summary of 10 lines. We want a summary of 500 words. These are the constraints. We want a summary that doesn't include certain things. We want to minimize time also. We want to minimize the sentence and the words also. So there are a lot of constraints that are available that can be mapped into with the help of optimization techniques. So if you have constraints, use optimization techniques. And if you have data that you don't want to use a deep learning model, for example, you have a totally different kind of a new model, right? A new thing that is there, and you don't want to basically you don't have the deep learning model language model learned about what is the relationship between words in that model, right? Every natural language can have a large language model with it, because a lot of information is available for it. We can train it, and it can be made we can learn the large language model. So but if we don't have that thing, for example, certain things, we don't have the context with it, in what context it is used. So in that case, we can still use the basic singular value decomposition, Latin semantic analysis to know the relationship between entities, right? An instance is gesture detection, right? We don't have a large language model for gesture detection right now, but we can use singular value decomposition on it, right? PCA is there, principal component analysis, matrix factorization is there, non-negative matrix factorization is there. Next tool was logic-based tools. You just have you can use the discrete mathematics techniques of proposition, predicate logic, but is however much restricted to theoretically. Reinforcement learning and transfer learning, I explained you what it means. Like you are developing a humanoid robot or a normal robot or a bot, and it wants to learn from the feedbacks given to it. Or transfer learning, you have learned it for a product A and you want to apply it on a product B. You just take that model and do some optimization. And approximate reasoning in cases when you are like there's certain uncertainty and you want to do decision making under uncertainty. So approximate reasoning can be used in other science applications for basically to use biological processes that are there, natural processes that are there, to infer certain things. So thank you all. These are the tools, and there are many other ways also, and I'll keep discussing about these in detail in the coming sessions. Thank you. Have a great day.